Hello, I am Derek Hudson, and today I'll be telling you about Sensor Platform, a project I did while I was a junior at Friendswood High School. Sensor Platform gathers the data from multiple types of sensors and relays the data wirelessly to a central computer. This system can be enhanced to provide remote data collection from uninhabitable or inaccessible locations, and used for monitoring weather conditions, hazardous environments, home security, or other potentially unsafe areas or situations. Next, I will be telling about my major steps for completing the project. First, I had to design the circuitry using the communication protocol that I had chosen, I2C. After that, I constructed the master and all of the slaves. After that, I planned and designed the software that would go on to each microprocessor so that they could communicate over I2C. I then programmed each individual slave for its specific sensor. Every different sensor had to have a different program. After that, I tested the assembly, the communication, and all of the sensing to make sure that it worked. Now I will be telling you the details about implementation. First, this is the Arduino Mega that acts as the master. The master controls all of these slaves. The purpose of the master is to send information that it gathers from the slaves to the computer. Because the electronics need energy, I had to design a power supply system. In order to determine that I had the correct input voltage, I put in a voltmeter. Once I am able to ascertain that the voltage is correct, I can turn on the rest of the project by using the switch. So, I will now power it up. Okay. The output of the power supply comes to the power bus. The power bus is connected to every single P8C connector, like the I2C buses, as well as to ground. Next, I put in a display so that I was able to read the status of several sensors. The right-hand column represents the communication status between the master and the slave. The left-hand column represents the slave's status. Every light in the left-hand column and in the right-hand column corresponds to a slave. The slave status is indicated by the LEDs on the slave as well as those found on the master. Every slave has its sensing element and a microprocessor. The microprocessor is what handles communication to the master. The sensing element is only ever pulled by the microprocessor on the same board. Every sensing element on every slave is unique. In order to read the outputs of the sensors, I had to hook the master up to a computer. The master has to be able to communicate to a personal computer. Because it is not physically hooked up, I had to use a Bluetooth controller to communicate to my computer. The one I chose to use is the Bluefruit wireless module made by Adafruit. Now I'll be talking about the slaves. This is just a handful of the ones that I've already built, and each one is unique. First one is the absolute humidity sensor. This one is the relative humidity and temperature sensor. This one is the GPS. This one is the MQ6 sensor. It can detect liquid propane gas as well as butane. this one, is the MQ3. It can detect alcohol, ethanol, and smoke. This one is the MQ2. This one detects a broader range of gases. The slaves communicate over a common I2C bus with the master. Each slave microprocessor is self-identifying and hot swappable. This slave's communication status is indicated by that LED. When I take the slave out of the array, that LED will turn red. Now I can plug this slave back into any open port, and that very LED will turn green again. Example, plug it in here. That's where it originally was. That LED is now green. Now I have the computer set up to receive data from the master and display it on the monitor. Every sensor has multiple messages or one message. Each message is a row. I will now look at sensor 4, or the relative temperature and humidity sensor. The first column in the row is the message number for that sensor. The second column is what it senses. The third column is the status of the sensor. The fourth column are the units of the sensor. The fifth one is how the computer should interpret that data. And the last column is the value, interpreted correctly. Now I will demonstrate one of the sensors. The sensor I will demonstrate is the relative temperature and humidity sensor, or sensor number 4. Currently, sensor number 4 is getting readings of 25 degrees Celsius and 36% humidity. Now, I blow into this, sensor number 4's temperature goes up by 2 degrees and the humidity goes up by 15%. While I worked on this project, I learned several concepts and skills. First one is mealtime programming, because the slave microprocessors have to communicate with the sensor element and the Arduino master. Next, I had to use advanced object-oriented concepts for the programming in order to complete this. My hardware skills and concepts were I had to solder over 2,000 connections, and I had to breadboard and learn how to design complex circuitry. Finally, I had to manage this project so that I could complete it over the course of a year. Thank you for watching this video about my sensor platform project. I hope you enjoyed it. What was wrong with that one?